Hello students, a very warm welcome to BYJU'S Classes. This is Nidhi and today we are going to discuss 26th February second shift mathematics paper which was held this year for JEE Mains conducted by NTA. Well, the next question is of limits and a very easy question. Let's see what the question is saying. The fx is a function which is differentiable at x is equal to a with f dash a is equal to 2 and f of a is equal to 4. Then they have asked what is limit x is approaching to a, x f of a minus a fx divided by x minus a. So, before finding the limits, what we have to do first? Well, right, we have to find which indeterminate form is it. So, when I put x as a in numerator, or let's say when I make my x approaching to a in numerator, it becomes 0. Similarly, or let's say it approaches to 0. Similarly, my denominator part again approaches to 0. So, definitely it's a 0 by 0 form. And since they involve, or let's say they have given us information about f dash a and f of a, that means I have to use these two informations. To use f dash a information, definitely I have to differentiate, right? That is clear. And for 0 by 0 form, when do we differentiate? When we apply L'Hopital rule, that's correct. So since it's 0 by 0 form, function is already differentiable, let's quickly apply LH rule. So let me take this limit as equal to L. So I can say that by LH rule. I hope you know what is my LH rule. What is LH rule? L'Hopital rule. When my numerator is approaching to 0, denominator is approaching to 0, and I have, let's say, limit x is approaching to a quantity, let me take b, such that gx and hx both are approaching to 0. This value is again equal to limit x is approaching to b, g dash x divided by h dash x, and we keep on doing that until we eliminate 0 by 0 form, right? Okay, so when quickly we apply L'Hopital rule, differentiating my numerator and denominator, it's going to give me limit x is approaching to a, derivative of x f of a, well, that is going to be simply f of a minus the derivative of a fx is going to become a times of f dash x divided by the derivative of x minus a is going to be only 1. And now since my 0 by 0 form has been eliminated, I'll just quickly substitute x value as a. So when I do that, it's going to give me f of a minus a times of f dash a. Or I can say that final my limit answer comes out as, when I substitute the value of f of a and f dash a, it's going to become 4 minus 2a. This will be the final answer. Isn't it easy? Yes, it is. We have to just apply the L'Hopital rule. Definitely, you don't have to leave this question and attempt it. Okay, so the final answer is with us and the right option will become C. Next is the question from coordinate geometry and that too from circles. The question is saying let A 1, 4 and B 1, minus 5 are 2 points. Let P be a point on the circle x minus 1 whole square plus y minus 1 whole square is equal to 1 such that PA square plus PB square has maximum value. Then what is the locus of PA and B, or let's say PA and B, they lie on a parabola, a hyperbola, a straight line or an ellipse. So I have to check whether PAB are lying on a parabola, hyperbola, ellipse or on a straight line. How are we going to do this? Well, I have to definitely find PA square and PB square and then apply the condition for it to be maximum. Clear? Okay, so quickly moving on to the question. It was definitely of a moderate level question. Circle is given to me, right? This circle will have its center as 1, 1 and the radius is also equal to 1. The circle will look somewhat like this. And then I have 2 points which they have mentioned to me. And I have to consider a point P, let's say somewhere here on this circle. Now, since they have mentioned me point A, which was nothing but 1, 4 and point B, which was nothing but 1, minus 5, I have to find distance between my point P, A, and similarly distance between my point P and B. So that means I have to assume some coordinate of point P, right? Now, generally, what do we assume the coordinate? Correct. Parametric form. We are going to assume the coordinate of P in parametric form. Center is with me, center is with me and radius is with me. So I can say that my P point will be nothing but x1 plus r cos theta, comma y1 plus r sin theta, right? And what is x1, y1? The center of the circle. So it's going to be 1 plus cos theta, comma 1 plus sin theta. And then I have my points A and B also. So now I have to apply the condition that PA square plus PB square is maximum. So quickly finding the distance between P and A, I can say that my PA square is going to become cos square theta. I'm just applying the distance formula, x1 minus x2 whole square plus y1 minus y2 whole square is going to become 3 minus sin theta whole square. And similarly, my PB square, distance between point P and B, again by going the same formula, it's going to become cos square theta plus 6 plus sin theta whole square. And now when I add, I'm going to get the summation of PA square plus PB square as, now guys, you can clearly see that cos square theta and here sin square theta will combine and give me 1. Similarly, cos square theta and here sin square theta again will combine and give me 1, right? So my 1 plus 1 value is 2. And then I'll have 3 square plus 6 square. So that is 9 plus 36. And I'll have minus 6 sin theta plus 12 sin theta. So finally, I can say that it's going to become 6 sin theta plus 47. This is the value of PA square plus PB square, right? Okay, so now I have to make it maximum, which is indeed very simple. What is maximum value of sin theta, guys? Well, that is 1, right? So that means I can say that 47 plus 6 sin theta maximum value will become 47 plus 6, which is coming out as 53. And when this is happening, I can quickly say that since my sin theta will be 1, my cos theta is going to become 0. My point P coordinate is going to become 1 plus cos theta, that is 0, comma 1 plus sin theta, that is 1, which is nothing but 1, comma 2. And you know that very well that if my center is 1, comma 1 and radius is 1, this is my point 1, comma 2. So this will be the position of my point P when PA square plus PB square will become maximum. And here you can clearly see that P, A and B, they all lie on a straight line. So that means P, A and B will always lie on this straight line such that PA square plus PB square is maximum. Understood? It was again not a difficult question. I would place this question in easy or moderate category depending upon, see, that depends upon student to student also. But what was the main thing here? To write point P in the parametric form, which made actually your calculation a bit simpler. Instead of if you keep it in x1 comma y1 form, it will be on a bit lengthier side. Okay, so this will be the point, this will be the locus that they lie on straight line, and the right option for the question will become B. Well, this question says if locus of midpoint of line segment from point 3, 2 to a point on the circle x square plus y square is equal to 1 is a circle of radius r, then what is the value of r? Okay. So, first of all, let's quickly plot the given circle. X square plus y square is equal to 1 is a circle having origin as the center, radius is 1. So, it's saying that from a point 3, 2, let's say this point as A, I have drawn a line segment to a point on the circle, right? And their midpoint locus is to be found out. So, I'm taking the midpoint here as h, k. So, I have to get the locus of this midpoint h, k. How will I get that? Well, what I can do is, if I take the midpoint as h, k and point A as 3, 2, can I get this point on the circle? Yes, that can be obtained, right? Because h, k is midpoint of these 2 points. And if I get this point, I'll put this in equation of the circle, which in turn is going to give me a relation in h and k, right? So we are going to use this approach, and from there we should get a circle and we have to find its radius. Clear? Perfect. So this is the circle. Then let's say Q is the midpoint and P is the point on the circle, right? So I have P point on the circle, Q is the midpoint, which is my h comma k. So quickly, by applying the formula that P and A has midpoint as Q, I can say that if I take my P coordinates, let's say as A comma B for some time, I can say that A plus 3 by 2 will be equal to h. That means my A value, which will be equal to 2h minus 3. Similarly, B plus 2 by 2 is equal to k. That means my B value will be equal to 2k minus 2. So now I have obtained A and B in terms of h and k, which is what we needed. And now we'll substitute the coordinate of point P in the given equation of circle. So when I do that, it's going to become 2h minus 3 whole square plus 2k minus 2 whole square is equal to 1. And here if I take 2 common from both the brackets, it will come out as 4. So it's going to become h minus 3 by 2 whole square plus k minus 1 whole square multiplied by 4 is equal to 1. And can you see what the locus came out as? Yes, it came out as a circle. So the final locus will be x minus 3 by 2 whole square plus y minus 1 whole square is equal to 1 by 4. And what we have to find out? Well, we have to find out radius of the circle, which is directly equal to 1 by 2 because it is expressed in center radius form. So question was easy. Yes, it was on easier side. You have to just find coordinate of point P in terms of h and k and put in the equation of the given circle. From there, what we have got? Well, from there we have got locus of point Q as again a circle, and the final answer is 1 by 2. Understood? Perfect. So the option correct will be B. Well, the next question says, let slope of the tangent line to a curve at any point P be given by xy square plus y by x. Now, what is the slope of tangent? Well, that is dy by dx, right? So that means they have mentioned that dy by dx is equal to xy square plus y divided by x. This is one information. That means question is from differential equation. They have asked further that if the curve intersects the line x plus 2y is equal to 4 at x is equal to minus 2, then what is the value of y for which the point 3 comma y lies on the curve? So if I have to find y, I have to satisfy 3 comma y in the equation of curve. And for that, I have to obtain my curve equation. That means I have to solve this differential equation. Isn't it? Okay. Now, how should we solve this equation? Well, it's not as in very easiest form, which is variable separable form. Right? We cannot just separate y and x and integrate directly. Okay, so then what can we do? Well, here are two things. You can either convert this into a linear differential equation, or you can apply definitely or you can convert this into exact differential equation. What is exact differential equation? Well, the equation or the differential equations which can be directly integrated, or you can also say that a differential equation which is obtained by directly differentiating the curve. Okay, so I'll tell you both the approaches. I will first tell you how to convert this into a linear differential equation. So for that, what you do is you divide this entire equation by y square, first of all. So when we divide the equation by y square, it's going to become 1 by y square multiplied by dy by dx minus of 1 by y multiplied by 1 by x is equal to 1. Right? And now I'm substituting minus 1 by y as t. Why am I doing that? Because my term 1 by y square into dy by dx can now be written as what? dt by dx, that's correct. So it's going to become 1 by y square dy by dx is equal to dt by dx which when I substitute over here, it's going to give me dt by dx. Then minus 1 by y is t. So it's going to be plus t multiplied by 1 by x is equal to 1. And now you already know this is a linear differential equation with your integrating factor as e raised to integral of 1 by x dx, which is nothing but e raised to ln x, which is equal to x. And after that, you can easily solve this out, right? Or you can convert this into an exact differential equation. How are we going to do that? Let me tell you that part also. You can apply any one of the approach, whichever comes to your mind first. So, I'm writing again my dy by dx is equal to x y square plus y divided by x. And now I'm just cross multiplying. So, it's going to give me x dy plus, equal to y square x dx plus y dx. Further can be written as x dy minus y dx divided by y square is equal to x dx. Now, this is similar to my exact differential equation because I can say that my right hand side part definitely is my derivative of x square by 2. Isn't it? And what about the left hand side part? Well, you can see somewhat a question form is written, right? So it will be derivative of minus of x by y. Because you already know when I differentiate x by y, it becomes y dx minus x dy. Here it's written negative of that. So therefore, I have derivative of minus xyy. So now I have my exact differential equation. I'll integrate on both sides. So when I integrate on both sides, I'm going to get minus of x by y is equal to x square by 2 plus some constant c. And now to get this constant c, they have mentioned that curve intersects the line x plus 2y equal to 4 at x is equal to minus 2. So that means if I put my x value as minus 2 over here, my y value is coming out as 3. That means this curve is passing through which point? Minus 2 comma 3. Which when I substitute here, I'll definitely get the value of c. Isn't it? So guys, quickly, if you haven't got this question, solve with me and let's quickly find the answer together. So my value of c will be, when I substitute my point, it's going to become 2 by 3 is equal to 2 plus c. That means my c value is minus 4 by 3. And therefore, my final curve come out as minus x by y is equal to x square by 2 minus of 4 by 3. And now what they have said, that this curve is passing through the point 3 comma y. We have to get the value of y. So when I put x as 3, it's going to become minus 3 by y is equal to 9 by 2 minus 4 by 3. And when I take its LCM, it's 27 minus 8, that is 19 by 6. That means my y value is nothing but minus of 18 by 19. This will be the final answer. They have asked us the value of y. So have you understood? This differential equation can be solved by two methods. You can use a substitution and convert into a linear differential equation, or you can also go by exact differential equation. I would like to put this question a bit on the difficult side, right? So this will be the final answer for us. And now if we look at the options, we can say the right one will become B. Well, the next question is from area under the curves, and trust me guys, it's not at all a difficult question. What the question is saying, let A1 be the area of region bounded by the curves y is equal to sin x and cos x and y-axis in the first quadrant. Okay, so first quadrant, I have to actually plot, let's say, sin x and cos x also. So the area is actually bounded between sin x and cos x and y-axis. Okay, so in first quadrant, if I have sin, cos and y-axis, they are talking about this part, right? So this is my A1. Moving further, they have said A2 is the area between the curves sin x, cos x, x-axis and till x is equal to pi by 2 again in the first quadrant. So that means if I have to take these four with to find the enclosed area, I have sine x, I have cos x, I have x-axis and pi by 2. They are going to give me this part. So this is A1 and A2. So in options, they have definitely asked us the ratio of A1 by A2. What is the ratio? And obviously the values of A1 plus A2. Okay, so that means I have to find A1, I have to find A2, I have to find its ratio as well as the sum. Clear? Okay. So now if I see this figure, what is going to happen? I have this curve, let's say, as my cos x. This point you already know, it's pi by 2. Can you tell me, guys, what is A1 plus A2? Well, in the figure, if I combine A1 and A2, I can easily say that my A1 plus A2 is going to give me this entire area, isn't it? And what is this area? Well, it is integration of cos directly from 0 to pi by 2, right? So that means I can clearly say that my A1 plus A2 will give me the area of cos x between 0 to pi by 2 with x-axis. Perfect. So we have got this much information with us. And when we integrate A1 plus A2, or when we solve for A1 plus A2, or when we integrate cos from 0 to pi by 2, you know the integration of cos is nothing but sine x. And from 0 to pi by 2, when we put the limits, value is 1. So that means A1 plus A2 is 1. That is one thing. Now I have to find A2, and integration of A2 basically is this part, right? So I have basically, or let's say I can, instead of finding A2, I can find A1, which will be integration of cos minus sine, because it's basically upper curve minus lower curve between the limits 0 to this value, which is pi by 4. So I can quickly write my A1 value, which is integration of 0 to pi by 4, upper curve minus lower curve, that is cos x minus sine x. So when I solve this out, you already know the integration of cos x, well, that is sine x minus the integration of sine x is going to give me minus cos x, which is going to give me plus, and the limits are from 0 to pi by 4. So when I put the values here, it's going to give me 1 by root 2 plus 1 by root 2 minus 1, that is root 2 minus 1. Okay, so now I have my A1 with me. I have A1 plus A2 with me. Definitely I can find A2, which will be 1 minus A1. That is 1 minus of root 2 minus 1. That is 2 minus root 2, can be written as root 2 times of root 2 minus 1. Why have I written this? Because now I can quickly get my ratio which is asked in the question, that is A1 by A2, which will be nothing but root 2 minus 1 divided by root 2 times of root 2 minus 1. And guys, what this value is coming out as? 1 by root 2, that's correct. So my ratio is 1 by root 2 and my sum is equal to 1. Easy question, right? Not at all a difficult one. And now if we look at the options which have these two informations, we can clearly say that my answer is going to be B. Well, the next question is really very interesting question, and it's a bit tricky also. It's not at all tough. But if you cannot observe the pattern, then you won't be able to solve the question. And for pattern, they have given us some hints in the options also. They have given us terms like ln2 or log of e by 2 to the base e. Why am I actually emphasizing these two options? Because what they have mentioned is that a and b are lying between 0 to 1 and tan inverse a plus tan inverse b is pi by 4. So this is one condition. They have asked value of a summation. This summation series is actually very enticing. Yes, here you have to observe the pattern which I am talking about. Directly, obviously, you can't find the values of a and b separately because they have given us only one condition. So what should I do? Well, if you look at the series, listen very carefully, guys. It's a very interesting question. If you look at the series, I'm separating my a terms and b terms. So my a terms are a minus a square by 2 plus a cube by 3 minus a raised to 4 by 4 and so on. And similarly, when I separate my b term, it's on the similar pattern, b minus b square by 2 plus b cube by 3 minus b raised to 4 by 4 and so on. Now what? Well, now is the thing which you have to remember. What is this series? A minus a square by 2 plus a cube by 3 minus a raised to 4 by 4 and so on. Does anything strikes? This is the series of logarithm. That's correct. This is nothing but ln of 1 plus a. Similarly, this will be ln of 1 plus b. These are my series which they have given to me in the question. I have to find this value. How are we going to solve further? Well, that is on a easier side. But have you understood? And now have you enjoyed the question actually? They have given us two different logarithmic series. That's it. Nothing much. Okay, so now moving to the question part, we have already seen that this series is nothing but ln of 1 plus a plus ln of 1 plus b. Now, they have mentioned tan inverse a plus tan inverse b is equal to pi by 4, and obviously a and b are lying between 0 to 1. So that means I can apply tan inverse x plus tan inverse y formula, right? So it's going to become tan inverse of a plus b upon 1 minus ab. This is the only condition. I mean, there will be no other condition. And this is equal to pi by 4. That means when I take tan both sides, I'm going to get a plus b upon 1 minus ab is equal to tan pi by 4, which is 1. And now when I cross multiply, it's going to become a plus b is equal to 1 minus ab. Clear? Okay, now quickly moving on to the expansion or the series part which they have asked. Ln of 1 plus a plus ln of 1 plus b is nothing but ln of 1 plus a multiplied by 1 plus b, right? So when I expand this, it's ln of 1 plus a plus b plus ab. Now I have to get value of this expression. I have arrived at this condition. So from here you can clearly see that a plus b plus ab is equal to 1. And when I substitute my value over here, it's going to be equal to ln of 1 plus 1, which is nothing but ln 2. This will become final answer for this question. So have you understood now? Have you realized? Generally, questions are not at all typical or they are not on the tougher side. What you have to do is be calm. Try to observe some pattern. They might have given a pattern. Sometimes we have to do a bit of cheating. We have to actually look at the options also which are given to us. From there, again, we might get a hint on how to approach to the question or which method to apply. So here when I separated out, it actually came out as summation of two different series, ln 1 plus a and ln 1 plus b. And rest of the part was easy, right? Perfect. So now if we look at the options, we can clearly say that answer will become A. Well, the next question is from mathematical logic. The question is saying let F1, which has three different statements A, B and C, it's nothing but A and negation of B, or negation C and A or B, or negation A. And similarly, I have F2 as A or B, or B implies negation of A. These are two logical expressions. Then we have to check which one of F1 or F2 is a tautology, or maybe both of them are tautology. That means I have to simplify F1 as well as F2. Clear? Okay, now we can do this obviously by mathematical reasoning concepts. We can apply different laws which we have read. Or to make it a bit simpler, what I'll do, I'll involve set theory. I hope you know how to involve set theory here. If not, don't worry, I'll teach you one more method. So what do we do in set theory is this and is taken as intersection and this or is taken as union. Simple as that, first of all. So using set theory, I can say that my F1 will become A and this negation of B becomes B complement. Then I have union, then negation of C is nothing but C complement. Then I have and which will become intersection. A or B, that means A union B. Then I have or, that means union. Again, my negation of A is nothing but A complement. Understood? So now I have to basically simplify this using my set theory. That means I can obviously draw a Venn diagram and find whether this is going to give me this entire sample space or not. If I get F1 as my denoting as my entire sample space, that means it has to be a tautology. If it's not giving me the entire sample space, that means it's not a tautology. As simple as that. Understood? Perfect. So now I'll try to simplify this. For that, I'll first concentrate on A and B complement union A complement, right? I'll combine these two by associative law. So when I write A and B complement union with A complement, what this region comes out as? Well, if I have, let's say this as A and B, I have A and B complement as only A part, right? And when I combine it with my union of A complement, so my union of A complement is going to give me this entire blue region, which is except A. So when I combine these two, I have everything except this smaller part which is left out. And this smaller part, the red one, is nothing but A and B. So that means I can say that this is coming out as finally what? It is coming out as A and B whole complement. Then I have to write union with C complement intersection A union B. And now I'll apply the distributive law. So when I do that, it's going to give me A and B whole complement union C complement. And then I'll have intersection with, this is my first term, then I'll have intersection with A and B whole complement union A union B. Clear? Okay, now I'll try to simplify my second term. Similarly, by Venn diagram, I'll try to go. So when I simplify my second term, let's quickly see what do we get. In my Venn diagram, which region it represents, I have again my A and B with me. A intersection B whole complement means all the region except A intersection B, right? And now I have to take its union with A union B. And guys, what is A union B? Well, A union B is this entire blue region. So when I combine these two, what am I going to get? The entire sample space, right? So this is going to give me the entire sample space. That means if I take my intersection of, let's say this is D. For some time, I'm taking this as D. If I take my intersection of D with sample space, I'm going to get D only. That means I can say that my F1 finally will come out as A intersection B whole complement union C complement. You can also write this as A complement union B complement union C complement, or further can be written as A intersection B intersection C whole complement. So is it coming out as now the entire sample space? No, it's not. That means this will not be a tautology. Clear? Perfect. Now coming to the F2. So my F2 statement is given to me as like this. Now what I'll do, this is my A union B. Again, I'm moving by my set theory. Then I have to write union. Now this B implies negation of A. You know what is B implies negation of A can be written as? Well, it can be written as negation B or negation A, right? That means my F2 finally is going to come out as A union B union A intersection B whole complement. And what does that mean? We have just seen here on the left hand side that A union B union with A intersection B whole complement gave me the entire sample space, right? So that means this is equal to entire sample space. And if it is giving me the entire sample space, definitely this will be a tautology. So that means my F1 is not a tautology, but F2 is a tautology. And we have solved just by the Venn diagram, nothing much. And which is very simple because I know you all are well versed with marking the regions in the Venn diagram. Isn't it? Perfect. So the answer is that F2 is a tautology while F1 is not. Therefore, giving me right option as A.